Hello. I'm really glad to be here. Thank you for bringing me all this way, to the conference organizers, and all of you for being here. We've had a full day. There's been a lot of information stuffed into the brain, so I actually thought I'd take a sort of a longer view, both into the past and maybe into the future. So I personally, I don't know about the rest of you, I have been working on the web since the fall of 1993, and actually online since about 1989. And in that time, I have sent and received a lot of email.
You've got mail.
Oh, thank you. Apparently I have more. But I remember when email was just a plain text format and mostly limited to the base Latin 1 ASCII set to boot. Right? But these days, now we have plain text in our emails, and we also have HTML in our emails. Right? There's the sort of traditional view, and then there's the spiffier view, although in this case without the images. I didn't load all the images. And you might be wondering, what does that have to do with CSS or even the web in general? But the way that this works is that the text of the message is actually split into labeled sections, right? So there's one section for plain text, and there's another one for things that should be parsed as HTML, and then there's this other section that's a PDF, and this other section that's a PNG, right? And so it takes this one thing and splits it up into labeled sections. Believe it or not, there's actually a thing like that for HTML. This element marks the text after it to be plain text, just like it says. So anything before this tag is interpreted as HTML, and anything after the tag is interpreted as raw text. So you might put a copy of the HTML content at the end of the document, right? This is sort of the stuff that was in the paragraph up there, and now it's plain text down here. So this was meant as a parsing and an indexing boost in the early web, so that search engines wouldn't have to guess how to parse HTML, because at the time there weren't really HTML parsing engines. So you could have this plain text alternative to your website. Alternatively, you could put different text there for whatever reason. The HTML specifications of the time, which weren't really specifications, they were more just summary documents, they weren't really clear about why or how you should use this. They just said that it was possible. So here's what the document would look like. Well, actually, it would look more like this, because at the time it was 640 by 480 pixels. But we have more pixels now, so I'll make it pretty again. Notice the HTML there in that plain text section is not parsed. It is treated as plain text. Everything is showed literally, which means if you wanted to end the element, there was no way to stop it. You would just get the /plain text. And if you had a /body and a /HTML, they would show up in your page. So this emerged in the midst of the early web. We don't have an exact date, but somewhere in 1990 is when this was first introduced. Support for this element lasted up through today. This element is still supported in web browsers. I took these screenshots in Firefox nightly just a couple of weeks ago. You can still plain text your web pages if you want. It's like pre, but with no parsing and no ending. Right? And early HTML actually had a lot of options for presenting pre-formatted text, each of which had its own quirks. Some allowed parsing of HTML inside of them. Others had raw text output, like the XMP down here at the bottom. Typewriter is actually a special case up there. This is actually what it looks like by default, again, in Firefox. See, listing an XMP being short for example, still have default styles in the web browsers that make them pre-formatted monospaced text, sometimes with parsing and sometimes not. Typewriter doesn't. It was so long ago, and support for it was in the specifications was dropped so long ago that there really isn't any default styling for it. So I wrote some basic CSS to make it look roughly like it would have 30 years ago. This is the CSS I used. okay? Here's the thing, though. I gave it a medium font size, and medium font size is the default. So why is its text bigger than these other elements' text, which is also medium? And the answer to that actually comes from somewhere in 1994, because that's when the font element was introduced by the Mosaic Communications Corporation's Netscape web browser. They started out being called Mosaic Communications Corporation. That's actually their first corporate logo. They later changed their name to Netscape Communications Corporation for various reasons, some of which were legal. But down this page, once you go past some interesting stuff like the origins of floating are in this document, all the way down here, there's this section about font sizing, which says you could size your fonts on a scale from 1 to 7 with a default value of 3. This scale applied to both the font and the base font elements. Still supported today, by the way. So here are those sizes with the default marked and the equivalent present-day font sizing values. This is what you would need to use to get the same sizing for each of these. Okay, so far so good. Maybe. But things get complicated a couple of years later. That's when CSS1 was published, which also defined a set of 7 font sizing keywords. Except here, the default value is in the middle of the scale, rather than to one side of the middle, which is a problem because imagine if you're an author who has published web pages and you've even maybe said explicitly font size equals 3, because that's the default value, and then you decide to switch over to CSS and you say font size medium, it's going to get bigger if something isn't done about this. So they shifted things to make medium equivalent to 3, which took the XX small and pushed it off the bottom of the scale, and it means that XX large is not actually equal to font size equals 7, but the defaults match, so that's good. And that brings us back to medium-sized typewriter. See, monospace fonts and proportional fonts look weird when they're set to the same size. Monospace looks way too big. It has to do with the letter forms and the X sizing, and it's all very complicated. I don't really have time to get into it now, but browsers have internal mechanisms that treat monospace medium text and proportional medium text differently. Typewriter doesn't get caught by those mechanisms because it's too old, in effect. So its medium is different than the medium for listing an XMP, which the browser knows to apply these special monospace mechanisms to. All of this being governed by the browser's preferences, where proportional is set to 16 by default, and monospace is set to 13 by default. In other words, font size equals 3, and font size equals 2. They're the same values. Now, this isn't the only place where we live with the ghosts of decisions past. I want you to consider the block quote, which debuted somewhere around late 1992. Again, the exact date is not clear. But if you inspect it, this in Firefox, you'll find that there are default styles that the browser applies. So in this case, I put in blue for the content area. Firefox actually has margin block start and margin block end of 1M, which are the top and bottom. Now, margin block start and margin block end are logical properties. These are actually coming soon to multiple browsers. The idea here being writing modes, which we heard about earlier. In the writing modes, sometimes the block direction is this direction, like it is in English or basically most Latin 1 and Cyrillic languages. But then in other languages, the block direction is this way or this way, as with, let's say, Japanese or Korean, at least some writing styles. Then margin inline start and margin inline end here are going to be on the sides, but if you use these logical properties, you can have a situation where you say, I want a certain margin to go at the beginning of the block direction. So if I'm writing in English, it'll be up here, but if I'm writing in Japanese, it'll be over here. Now, margin top, right, bottom, left will still exist and still be supported, but this is much more language direction agnostic. So anyway, the top and bottom or in this case, the block start, block end margins are 1em, which means that they're scaled to the text. But the inline start and end, which here are the right and left margins, are 40 pixels. They're not 2.5em, they're not anything else. They're 40 pixels, exactly. No matter how big or small you make your text, 40 pixels. This is not the only instance of pixel margins that we still experience. The body element has an 8-pixel margin all the way around it, instead of half an em, if you want to go from 16 pixels as a default, or even 1/25th of the viewport, or some other measure. Why is that? Why is it 40 pixels on the sides of the block quote and 8 pixels around the body? And the answer is, it's all because 30 years ago, that's what Mosaic did. And as with a lot of these things, we don't know exactly when this happened, right? Sometime in 1992 or 93, a programmer at the National Center for Supercomputing Applications, or NCSA, in Illinois, in the state of Illinois, in the United States of America, somebody was tasked with rendering the various HTML elements. I don't even know who that was, but somebody said, all right, they're going through the list of elements, block quote. All right, it should probably have a blank line before it and a blank line after, just like we have with paragraphs, but then it needs to be indented. 40 pixels, why not? Right? And rather than have the content of the body element like jammed literally right up against the edges of the browser viewport, it needed to be pushed in a little bit. How much should that be? Somebody just decided, probably one person decided 8 pixels. And this is still in browsers today. And as I say, we don't know exactly when that happened, somewhere in 1992 or maybe early 1993, but sometimes we do get precise dates for where these things came from. One such date is the 25th of February in 1993. This date can be argued to be the beginning of what we think of today as the web. Because on that date, Mark Andreessen at NCSA, who was working on Mosaic, sent email to the www talk mailing list where he said, I'd like to propose this new HTML tag called IMG. And it'll have an SRC attribute that points to an image file, and then it'll pull in a bitmap or pixmap, as he called it, something like a JPEG or a GIF or an XBM, which was a very popular image format at the time. It's okay if you've never heard of it, ask your grandparents. But see, to be embedded in the text at the point of the tag's occurrence. Before this, images were not embedded in web pages. If you wanted to show an image in conjunction with a web page, you would hyperlink to it, the user would click on it or otherwise activate it, and it would open in a separate window. This is why images are embedded in pages. So some discussion ensued on the list. One gentleman said he'd envisioned a more generic approach. He said, rather than IMG, let's use include, or if that sounds too much like a programming include, we could use embed, because that way, rather than just being about images, anything could be embedded. Like later on, if we think about putting in audio files or video files, we could just embed them the same way we embed images. Maybe this PDF thing I've heard Adobe is working on, maybe we could embed those in web pages as well, right? Very sort of file system agnostic. The person who wrote this email was Tim Berners-Lee, the guy who invented the web. So a couple of weeks later, Mark Andreessen followed up to say, we're probably going to go with IMG SRC. And that's what they did. And that's why we have an image-specific element. And by implication, we also have specific elements for audio and video and other such things. And honestly, this is probably why responsive images have been so difficult to deal with. Because rather than have an embed container where you could specify a bunch of different images, when they started out, they had to figure out a way to stuff all that information into an attribute of the IMG element. It's also interesting to see here that Mark talks about how later on we'll probably support being able to say what the MIME type of the image is. But for now, we don't really need to do that because our routines automatically can tell what the image type is. When's the last time you explicitly specified the MIME type for the image you were using in IMG? You don't have to raise your hand. The answer is never, because nobody ever had to. But that led to a web where images could be part of the page, as with this early site for Novell. This is one of the first Novell websites, or this beauty from Microsoft. Very CD-ROM-esque, and probably where they got this design from. They probably had a CD-ROM that they'd been shipping to customers, and they said, ooh, we have this thing, we could put it on the internet now. Let's do that, right? This is actually one big image using elements of map and area to define which parts of the image you could click on. It's actually kind of inventive. I mean, I look at this now and I think, I don't see websites like that. How come I never see websites like that? But anyway, note the text at the top, not the where do you want to go today, but right under it, it says, if your browser doesn't support images, we have a text menu as well. Right? Because this was a time, 1994 or so, where lots of browsers, even though IMG existed, still didn't support it, either because they hadn't been updated, or because the implementers didn't think it was interesting, or in some cases where there was no way that the browser ever would be able to. Which leads me to sort of my next thing, which is another example of elements dropping into HTML, which comes from our friends at Netscape, and also a fair amount of alcohol. So, this is a story from Lou Montulli, who was a lead engineer at the time, where he wrote this up a few years ago, where he talked about going out to a bar with some engineers, and at one point in the evening, he says, yeah, we're talking about all these new extensions to HTML, this cool new stuff that we're going to be able to do in Netscape and maybe other browsers, but who cares about them? But Lynx isn't going to be able to do that. So, okay, let me back up. Lynx is a web browser that basically runs from the command line. So if you've ever used VI or Emacs, it's like browsing the web in one of those, which actually you can do in Emacs because you can do everything in Emacs apparently. But it's a command line terminal-based text mode browser. Still exists today, but you know he was saying, oh, it's sad that Lynx isn't going to be able to do that, right? That was a concern because of the number of people still using that sort of a browser. And he pointed out that really the only text style Lynx had available to it was to make text blink, which they all thought was hilarious. Oh my God, blinking text, what would that be like? And then the next morning, he went into the office, and one of the engineers who'd been drinking with him went back to the office, presumably still drunk, and implemented blinking text overnight. When Lou got there in the morning, it was done. And he was very proud of it. And that is where we got the blink tag. Now, a few months later, Microsoft decided to come out with their own thing. They said, blinking tag, they have blinking text. We're not going to do that. That's so gauche. We'll have text scroll from side to side instead in a marquee. As Jay Hoffman says, we don't know whether alcohol was involved in this decision, but it's a fair presumption. But then a couple years later, HTML 3.2 came out, and it had all these elements. These are all elements from HTML 3.2. You will not find blink, and you will not find marquee. Because by mutual agreement, the two organizations, Netscape and Microsoft, agreed to leave them out. It was basically okay, so you came up with a crazy tag, so we came up with a crazy tag. But if you leave your crazy tag out of the specification, we'll leave our crazy tag out of the specification. Right? Sort of a mutual assured destruction kind of thing happening there. I mean, it was these people grew up in the Cold War, so maybe that made sense. But regardless, the two things stayed out. It was by agreement, and it took a very long time before they got anywhere close to the specification. But Netscape kind of had the last laugh. Because in 1996, CSS1 included blinking text with text decoration, but not scrolling text. Right? There was no marquee effect in CSS1, but there was a blink effect. But there's an interesting line in the specification. It says user agents, which is W3C speak for web browsers, user agents must recognize the keyword blink, but they are not required to support the blink effect. Right? So basically, we can imagine this, the Netscape representative on the working group saying, we want blink on text decoration, and the Microsoft representative saying, like hell. And so the compromise they reached was, all right, we'll have it in the specification, and browsers have to recognize that it's valid CSS1, but they don't actually have to do the blink thing. This choice actually echoes into the present, which I can demonstrate with this HTML and CSS. So the intent, so basically what this says is, this first paragraph that I have, blink the text decoration blink. And then the second paragraph, set the background to red. But if you support text decoration blink, actually change that second paragraph's background to lime. So the intent here is browsers that don't blink the text should show red, and browsers that do blink the text should show green. So in Firefox, there is no blinking, and yet there is a green background. In Chrome, on the other hand, you get exactly the same thing. Because these browsers do recognize text decoration blink, just like CSS1 said they should, but they don't enable the effect. Because @supports doesn't mean what you or I might think it means. It should really be called @understands or @parses, right? @supports means I recognize this is valid CSS. It doesn't mean I'm actually going to do it. What's interesting is that in Opera, the text blinks, but the background is red. I can't explain that one. I thought it was that Opera didn't support @supports, but it does, so I got nothing. But other tags beyond blink did shape the CSS behaviors of today. Remember these guys? Some of you? I know very few of you raised your hands, but some of you remember. Right, so 1995, we got table markup. The web had already existed for 5, maybe 6 years before there was table markup. So we couldn't even use tables to lay out things, they didn't exist. But then tables came out, and people went crazy. This slide is from a talk that Jen Simmons does, and she got these images from David Siegel's book, Creating Killer Websites, which came out in 1996. Like, this is a web page, this one in the middle right here. It's a great big image that got sliced up into a bunch of pieces and then jammed into table cells. It's super inventive. Like, I don't see anything like this on the web today, basically. But, I mean, from an accessibility point of view, from a development point of view, it was a freaking nightmare. But people did this kind of thing. And one of the things that made this work was being able to fill table cells with colors using BG color. So here's another example. This is from CNN, the end of 1996. And if you see, I mean, this page is laid out with a table, possibly more than one. And that stripe, the sort of column separator, that's very likely a table cell that's like 1 pixel wide that has a transparent image in it, probably called spacer.gif, and then a BG color equals black or dark gray or probably octothorpe 000000, whatever it is. But that's where that separator most likely came from. But you could do BG color in more than just table cells, as you can see at the top of the page there. You could actually also apply it to body. At the time that table markup came out and BG color was announced as one of the things you could do to table cells, it was also extended to the body element itself. So this, it looks kind of whitish, but it's sort of a cream yellow. That is a body BG color that's sort of spread out to the entire page. You could even assign an image with background and have it infinitely tiled, as on this classic website, Space Jam, the original Space Jam, not the remake they're doing now. But this page is still online. That URL works. You can go there today and inspect the source. And I encourage you to do so, because this is pretty cutting edge 1996 design right here. And you can see how it was done. But regardless, the background attribute was used to point at this, little image of the stars, and then they just get repeated infinitely, just like CSS1 does with background images, and now you know why, right? But this is a little bit weird, actually, when you think about it from a current perspective. These are backgrounds, either colors or images, that are being assigned to the body element. So they should fill the body element. But the body element is not necessarily the entire page. The body element should only be as tall as its content, right? So, but instead, what happens in browsers is that it spreads out to the HTML element, if that fills the page, or if it doesn't, the entire viewport. Even though the actual CSS height of body could, and in this case is, much shorter. The reason for this is that CSS2 addresses this situation with magic language. There's no algorithm, there's just this paragraph that basically says, in effect, take the background of the body, and if the HTML's background is transparent, clone, inherit the background upwards in the document tree so that it gets applied to the HTML and it fills the viewport. But if HTML has its own non-transparent background, then don't do that. Have HTML's background fill the entire viewport, and the body's background will just be constrained to where it is. This behavior actually happens in more than one property. There's all the background properties where it holds true, but there's also the direction property. If you set a direction on the body element, it actually gets hoisted upwards to HTML. Writing mode, the same, which you might think, okay, why does that happen? And there are subtle reasons, but overflow is an example. If you set an overflow on the body and it doesn't conflict with an overflow value for HTML, the value of overflow for body will actually be lifted up and used to set how the viewport acts, which is what we would expect as authors. But there's magic language that makes it so we don't have to think about it. There may be other properties. I'm not sure I found all of them, but CSS itself created some weird outcomes. The box model. The box model. From the beginning, right? And the W3C's box model was additive. You set height and width, and then it added padding and border and margin around that. But Internet Explorer implemented a subtractive model where you set height or width, usually width, and then the border and the padding were inside of it, and the content size was subtracted by that amount, which arguably makes more sense. When you set a visual width, you probably want it to apply all the way out to the edges of the borders instead of just being the content area. But the W3C specified it one way, and Internet Explorer implemented it a different way. And by the time this came up in the working group, it was too late to fix it. Internet Explorer had shipped. There were thousands or millions, possibly, of web pages that depended on this box model interpretation. But on the flip side, there were thousands or possibly millions of web pages that depended on the W3C model, because Netscape had already shipped that implementation, and at the time, Netscape had approximately 95% of the browser market. Not an exaggeration, they literally had 95% of the browser market at that point. CSS almost strangled to death on this incompatibility. But Todd Farner, who has since retired from web work altogether, proposed Doctype switching. Some of you may have heard of this, or possibly even depended on it, where certain doc types, or the absence of a doc type, would cause browsers to render things however they used to, but the presence of other doc types would cause them to stick to the standards more closely. And so there very quickly became a quirks mode, which, if any of you have read PPK's quirksmode.org, that's literally where he gets that name from. And then there was a standards mode, except it couldn't, of course, be that simple. Eventually, there was this compatibility table of standards mode and quirks mode and almost standards mode and error mode, or whatever E stands for, right? Like, for each of these doc types, there was all of this documentation of what browsers would actually do. The almost standards mode, by the way, actually my fault. I'll tell the story later if anyone wants to hear it, but this was a way to escape that bind, where there were two different ways that that the box model was implemented. This is how we got out of that trap. There were other techniques that came up at the same time, like hacks based on bugs in the CSS parsing engines, like this one, which was called the box model hack, even though honestly it should have been called the voice family hack. But it basically in older browsers that didn't do doctype switching, but you still wanted to like do a trigger. In the browsers that you wanted to target, that curly brace there, because they had bugs in the parsing of the CSS before that, they would end the rule there. So they would only see width 400 pixels. But in more recent browsers that didn't have that parsing bug, they would keep going and override the 400 with 300 or whatever value it was you needed. Right? These were a bridge, in effect. And all of this is why we have the property box sizing and why the default is content box, not border box. This is why when you set up a web page, you have to explicitly set things to have a box sizing of border box, rather than that just being the assumed default. And the twists and turns of web history extend all the way into the way that we write HTML itself. You may have noticed that so far all of my HTML examples have been uppercase. Because in the first several versions, which, there was never really a 1.0, but there were a bunch of releases around that time. But in the first several versions of HTML, all the examples were uppercase. All the tags were uppercase in the examples, even though HTML was, and still is, case insensitive, so that was essentially an arbitrary choice. But then, XHTML came along. Just as HTML 4.01 was being released, 1.0 came out. And XHTML was an XML formulation. XML is case sensitive. It mattered. So they had to pick, when they wrote XHTML, do we use uppercase or lowercase for our tags? They chose lowercase and kept that through the next versions, which took a decade to come out. So this is the first code example in HTML 4.01. Right, it's the first markup example, and everything's uppercase. The first example in XHTML 1.0, you can see everything's lowercase, and also there's some extra stuff up there at the top to satisfy XML parsing requirements. And then there's the XHTML 1.1 version, which has a lot more complicated stuff at the top. And then XHTML 2 came along, which was a lot less complicated. Of course, still lowercase. But there was a slight problem with XHTML 2. What happens if these two tags are flipped? These closing tags? In HTML and XHTML1, it was what you'd expect today, which is the browser just kind of recovers. It says, all right, you opened a paragraph, you opened an anchor, and then if these get flipped, oh, you closed the paragraph before you closed the anchor, so I'll quietly close the anchor for you, because I know that's what you meant, and then I'll just ignore this extra /a. That's what browsers do. In XHTML2, you got this when you loaded the page, an error message. No content, no fallbacks, no forgiveness, just error. So if your template got things unbalanced, this is what your users would see. Or more likely, because it was minified, they'd see that. Or maybe column 1180. Regardless, this is why we don't use XHTML2. Exactly this. Right? Because by the time HTML5 had come out, the industry's preferences had shifted. Right? XHTML's lowercase requirement had become the industry's preference. All the examples in HTML5 use lowercase markup, even though uppercase is completely valid. You can uppercase all of your HTML today. Browsers will be fine with it. But all of our tools output lowercase, because XHTML, through its requirements, set a tradition that we still unthinkingly uphold. And so here, an HTML5 equivalent of that XHTML2 error example just shows red closing tags in view source, which is basically saying, hey, there was a parsing problem here, but I dealt with it, it's fine. Right? Still functions perfectly well for the user. You can see these red tags in other places. Like here, the very first tag is in red. This is one of the very first web pages ever made back in 1989. This is the entire source. I cut out nothing. There's nothing after line 17. Okay? But this isn't actually broken. It's just unexpected. The browser says, whoa, you started with title. Where's the head? But you don't need the head, as it turns out. Not really. because HTML and body weren't actually part of the first draft of HTML. They came later, in HTML's case, a couple years later, which means they're optional. In order to preserve compatibility for those first web pages in web browsers, HTML and body elements had to be optional, and they still are. That fundamental design principle of HTML itself, and also of CSS, is why plain text content can still be seen on the web today. And it's also why content and elements that were created in just the last few years will be visible to a browser from 1994 or even earlier. That backward and forward compatibility is a defining feature of the web, and it's one of its greatest strengths. The most powerful core web technologies are designed to be compatible forwards and backwards in time, even when that comes at the cost of adding new features. Compatibility is prized over novelty. Similarly, the web prizes flexibility over rigidity. The ability to have these soft errors and keep going, the heavy lifting that browsers do to make sense of mangled markup or half-written CSS, all grows from that ethic. At the most basic level, the web prizes ubiquity over consistency. That's the essence of accessibility right there, in the sense of maximizing access to information above all else. The idea that someone who has a web browser from 1994 can still see the content of the page you developed in 2019, assuming you didn't do it completely driven in JavaScript, right? HTML is designed in that way, and also so that a web browser that was literally released this morning can still load the very first web pages that were written in 1989. The idea that someone with a flip phone, a feature phone, as they're called in the industry, can still get content from CNN.com even if they're not loading images and they're not running the JavaScript, right? That is accessibility at its core. Those principles, even though they may sometimes cause us to tear at our hair in frustration because we don't have an obvious error message pointing to exactly where the problem is, are, as I say, the web's greatest strengths. They are the reason it has spread so far and changed so much in the past 30 years. And by sticking to those principles, it will continue to serve you and me and everyone who uses the web through the next 30 years and beyond. Remember those principles and cherish them. Wielkie dziękuję. Thank you. Do I go to the comfy chair now?
Yeah.
I go to the comfy chair. Awesome. I'm going to snag this. Hello.
Okay, let's start.
Thanks for your talk. One man sends us this question. Do you miss the blink tag? Because I do.
I'm sorry?
Do you miss the blink tag? Because I do.
Do I miss the blink tag? No, I do not.
Very short answer.
Okay, what tags do you think would be desirable for developers to use less or be removed from the specification at all?
I would imagine basically no tags will be removed from the specification for exactly the reason that I talked about, right? There needs to be that forward and backward compatibility. There are some interesting elements that are being developed for web components so that web components can be supported at the markup level instead of having to be just a bunch of divs with JavaScript on top of them. I'm not sure where exactly that's going to go in terms of what they're called. Like the last one I saw, there was a slot element, which apparently you could put things in a slot. I don't know. Whether it's called that or not, we'll see. But the idea basically being, you know, this is being done a lot, so there should be elements to support that.
Okay.
If you had a chance to change anything about the web, what would it be?
If I could change anything about the web, what would it be?
Or maybe history of the web?
Gosh. It's hard for me to imagine changing anything about the web as it is, because it's been so phenomenally successful. I feel like it would be the height of arrogance for me to say, oh, I know how that could have been better, right? For me, I think it's more if I rubbed a magic lamp and a genie came out and said, I'll grant you 3 specifications that will be instantly implemented everywhere, what would they be? I'd have to think about it. I think exclusions would be high on that list, which got mentioned earlier today. I'm not sure what else. But yeah, I think it would be to push forward and to add things rather than to like try to change anything, take anything away or change the behavior of anything.
What is the craziest or funniest hack you ever did?
The craziest or funnest hack I ever did?
Yeah.
I was, well, I don't know if this was exactly fun. It was more evil. But back in the day, you could do body, and then you could do blink, and then you could do marquee, and then you could close them at the end of the body. So either the entire page would blink, or the entire page would marquee, or in a very limited number of implementations, would do both. That was always fun. And then actually in the early Netscape days, if you could animate the title of the window, the title bar, by having just a bunch of titles where the first title was, let's say, the first letter of your title, and then the second title element had the first 2 letters, and the first 3 letters, and the first 4 letters. And the browser was so slow at parsing them that they would literally animate the text out. That was also pretty bad. I'm going to say I think it was, I think probably my favorite hack at the time was when I took unordered lists or tables and turned them into bar charts, which was 13 or 14 years ago now. The reason for that being that that was the example that a lot of people point to when they say they realize that CSS doesn't care what you think an element should actually look like. CSS will just help you make it look like something. So you can have a table of figures, but then turn them into a bar chart, either way. It's fine, you can do that. I mean, you might have to look out for accessibility problems, but still, I think that's probably one of my favorites.
Okay, one more quick question. How do you think, is your reset.css irrelevant in 2019?
Yeah, our reset's irrelevant. I don't, it's hard for me to say. I didn't think more than, a couple dozen people would ever use it in the first place. I'm really sad that in the original reset, I said outline 0 for focus, but then I had a comment next to it saying, remember to be sure to set a focus style. Nobody ever did. I shouldn't have done that. I should have either left it out or I should have set a focus that was like eye-wateringly bad or something, some kind of very basic focus and then put next to it, hey, you can change this. But that was a big misstep on my part. What I see people doing is taking resets and turning them into reboot style sheets, so like normalized.css. Anyone normalized.css users? Okay, yeah. Where it's an opinionated reset, in effect. It resets a bunch of stuff, but it gives you a default appearance. That was what I always thought people would do with resets, is they would make their own normalized.css type things. So like, oh, in our shop, we have a look we start with. That's what I figured people would do. Instead, WordPress put reset.css like literally unedited into every theme for approximately a decade. And so they were so popular, people said, oh, we must need to have that. And unfortunately, it spread. So I would like it to be irrelevant, but I don't know that it is, sadly. It's sort of become my albatross.
And the last question, what do you think about Opera Mini?
What? I'm sorry?
What do you think about Opera Mini?
What do I think about Opera Mini? I like that it's there to put a little bit of red in our support charts. Not so much because I think it's a bad thing to use advanced properties, but it's a good reminder to us that, hey, not every user is going to be able to do grid or at supports or whatever it is, right? It's that little bit of, oh, hey, there are still browsers that don't, are still users, people using browsers that don't support the latest cool thing, and that doesn't mean I have to not use the cool thing. It means I just have to be careful not to use it in such a way that I break things for people who are on feature phones or are using the Windows 95 install in a public library that like they could never go past Internet Explorer 7, but they've somehow kept it going all these years. In the same way, in that same way, I liked it as there because whenever someone goes to can I use, it's never all green. To make them think, oh, the entire world is able to do that. There's that one little, oh, by the way. So, yay, Opera Mini.
Okay, thank you very much. Now please choose the best question.
The best question. I'm going to go with the what would I change about the web if I could, because it's the one that basically stumped me.
Okay.
So that was the best question.
Thank you.
Thank you.
Thank you very much.
Thanks.